Very loud. Thank you so much for coming to my talk. This is my second year presenting at scale. I had the pleasure of speaking here last year as well. I gave pretty much the same conference talk on a pretty short notice. I discovered the conference about 7 days before it was set to happen, reached out to Elon, the event coordinator, and was like, I have an idea for a talk. Is there any chance you could fit it in? Somehow he did. I ended up writing most of it the last 2 days before I was set to give my speech. And I presented this, how I started a hardware business at 18. Last year I did this on the security track. This year I'm taking a little bit more of a skew towards a hardware perspective. Because I'm talking about a business that has multiple dimensions to it. I create a cybersecurity focused educational hardware platform. That's a lot to unpack. But this time I'm going to be talking about it more from an analytical perspective in terms of what I think constitutes a good product design, walk you guys through the process of how I created this particular tool, and hopefully give you some pointers based off mistakes that I made along the way. So I'm going to dive right in by first giving you guys a brief outline of what this talk is going to look like. So at a high level, we're going to be talking about some criterion for what I think makes an effective product design. I'm going to be giving you guys a short timeline of the device that I created, which is called the Nugget. And then at the end, we're going to do a brief analysis of how I sort of scaled this into a cohesive brand. Before we do that, I first need to qualify some of the points that I'm talking about, and I'll first give you a backstory about myself, how I got here, and also, I guess, what makes me qualified to speak to you. In terms of the topics that I'm hoping to cover with this talk, as I said, I'm skewing this more towards an educational perspective. I designed an educational hardware tool, so I'm going to try to keep that at the focus of what I'm talking about. And then also, this is an open source Linuxy conference, so I'm going to also try to hit some points there as well in terms of open source hardware and things within that purview. So a little bit about me. My name's Alex. I am a 19-year-old hardware hacker, content creator, and InfoSec presenter. I mostly do freelance work, which is to say that I'm unemployed. But if you guys are familiar at all with Hack5, have any of you guys heard of Hack5? Yeah, so for those of you that aren't familiar, they create a wide range of pen testing products. They create like the USB rubber ducky, and basically a whole bunch of really cool tools for cybersecurity engagements and hacking. My primary job is I create content for their YouTube channel. I create educational hacking content for beginners, create video documentation, guides, and stuff like that. And when I'm not doing that, I love to build and destroy hardware. So I run a personal brand and side gig called Lynd Labs, where I take commissions to create mostly wireless-focused products, embedded devices, and things like that. Besides that, I'm also an instructor. I host workshops, primarily with the device that I create, and I also give talks like this one. To learn more, you can check out my website. So what I do for fun, so you guys are probably questioning this picture, but I destroyed my phone 2 days ago and I wasn't able to find any good pictures for representing my hobbies, so this is me looking really cool. So things that I do when I'm not doing nerd stuff. I enjoy skating. I enjoy war driving. If you guys aren't familiar with war driving, this is pretty interesting. It's basically a combination of wireless reconnaissance techniques. It's where you drive around with a Wi-Fi dongle and a GPS and you map Wi-Fi networks, vulnerable devices, and stuff like that. I enjoy doing that, and sometimes war skating as well. That's actually how I smashed my phone. Besides that, I enjoy urban exploration, so climbing on top of things and going places where I'm usually not supposed to be. And then besides that, I love music. I love playing music, creating music, and listening to music. I guess it's boring. Specific genres, I like jazz, R&B, and things within that scope. So now we're going to talk a little bit more about me. So where do I come from? How did I get to the point where I am today? How did my hobbies and interests sort of culminate in the creation of the design that I'm going to be talking about? So to start off with, we're going to go back to 6 years ago. Is that right? I don't know. Whenever I was in middle school, I'm 19. So what really piqued my interest in sort of this area, hacking and making and everything like that, was I hated middle school. I didn't want to pay attention in class. But I had kind of this romanticized idea of like hackers that I saw portrayed in the media, in movies, and things like that. I always found that really intriguing. I also grew up kind of poor, so I didn't have a computer. I didn't have internet until like my 3rd year of high school. So I guess in some sense it was this tantalization that drove me to become like really interested in wanting to learn how to not only work with these systems, but break them and hack them and all that cool stuff. So the first computer that I got was actually an 8-bit computer in middle school. It was my TI-84 calculator. If you guys have seen those calculators, they're quite clunky. They're like a brick. They have a full keyboard. You can type on them and stuff like that. But one day, also sorry, I'm loaded up on caffeine and chocolate right now. That's all I've had today. Trying to put this together in short order. So my friends and I used to pass notes on these calculators in math class because we were bored. But one day I discovered that you could actually write programs on these things in a language called BASIC. So that was really cool. And I ended up spending most of my subsequent lunchtimes and after school in the library, like learning how to write code on these things. Soon enough, we were creating video games. We even created like inter-calculator messaging apps where you could hook up a headphone cable between calculators and like text each other during class. So this was a whole thing for me. That's sort of what piqued my interest in programming, and that's where I got my start. Soon enough, some teachers caught on. They banned the calculators from our tests because we were doing all sorts of stuff that we weren't supposed to with them. And this is what introduced me to microcontrollers. So they were like, hey, no more of that stuff. You guys are doing naughty things on your graphing calculators. So now you have to use 6-function calculators because you can't hack them. So I took that as a challenge. I had a friend that was working with microcontrollers, so I consulted him. And we actually taught ourselves basically enough of like Arduino to figure out how to rig up a microcontroller to the internal circuitry of a 6-function calculator so you could intercept key presses, write your own programs on them, and then have them store formulas that you could access during tests and stuff, basically just to spite the teachers. So that's how I learned about microcontrollers. I found them really interesting. And I still work with them today. I think they're really great, particularly for hacking applications because of the low cost, and that's something that I'll get more into in a second. So yeah, oh yeah, another picture of me looking cool sitting on a toilet in the streets of LA because I don't have any pertinent pictures from my broken phone. So after that, I ended up getting my first computer, which was a Raspberry Pi in the 8th grade. I started teaching myself about all sorts of other script kiddie things. I picked up Kali Linux, started teaching myself about Wi-Fi hacking, actually. So one of the things was I didn't have, as I said, internet growing up. So this was a huge pain in the ass. I spent multiple nights like outside a Starbucks with my mom just so I could submit school assignments and things like that. And it really sucked. So once I discovered that it wasn't that hard to crack Wi-Fi networks, this was one of the first things that I taught myself how to do. And that really sparked my interest for signals intelligence. And again, this is all going to culminate into how this product was developed that I'm going to be talking about. So signals intelligence, microcontrollers, these were all things that I was really interested in. But then also I sort of discovered a passion, I guess, for education somewhere along the way. I'm not exactly sure what sparked that, but I decided to start creating content to document what I was working on. I started creating YouTube videos showcasing some of the projects that I was doing. And I learned about things like the open source community. I guess through mostly using open source tools. I was poor, I couldn't afford like SolidWorks and things like that, but yeah, we'll talk about how all of that converges in just a second. So this is one of the very first signals intelligence projects that I worked on, which was called the creep detector. This was the first time I got to explore actually using some of the skills that I got from the various nefarious things that I was doing. So this was a really fun project. Basically, I used war driving, which is the act of, as I mentioned, driving around and gathering Wi-Fi intelligence to create a proof of concept where you could detect if someone is stalking you. So the way that that works is your phones emulate something called a probe request when it's looking for networks it's connected to in the past. So as a fun little side project, I basically wrote up a Python script that allowed me to use this technique in order to determine if someone was following you along multiple GPS coordinates. And this was my first really signals intelligence oriented type project. So this is the first embedded project, I guess, that I worked on. And the reason why I want to showcase this one is this also laid the groundwork for the design that I'm talking about today. So I created this, I think, about 2 years into high school. I didn't know a whole lot about microcontrollers, but some random dude on the internet saw my other project, the creep detector, and was like, hey, you look smart. So I lost my phone, and I need you to help me track it down. He was like on a rafting trip and lost it in a forest or something like that. I wanted money, and this guy said he would give me $200, so I was like, yeah, I can definitely do that. So using the technique that I talked about in the previous slide, what I did was I ended up learning enough about microcontrollers, because that's all he had the budget for, to create a custom device that was able to hunt down for probe requests, specifically from the MAC address of iPhones. And not only was he able to use this to track down his phone, but he found a whole bunch of phones that other people lost in the area, because it was like a tourist spot. And that's how I got my first cell phone, because I didn't have one up until that point. So he just shipped me a Samsung Galaxy S7. Dang, I thought I had a slide here. But this was my first time really creating an embedded product, specifically for signals intelligence. So this is a completely different world than something like a Raspberry Pi, which is really extensive. It's a full-on computer. Embedded is completely different. You have to code everything from scratch. And I had to teach myself like all the skills to basically create like a fully packaged product to do that. This ended up building a lot of the foundation for the Nugget project that I'm going to talk about. It uses the same microcontroller and everything. So keep that in mind. We'll get to that in a second if I can find the right slide. And then throughout high school, I was also really bored. I didn't quite enjoy my classes. So what I did instead was I taught myself more about the world of embedded devices. I worked on more signals intelligence prototypes. And I got a bunch of really weird requests. Like this one down here was a Wi-Fi controlled sound box that someone wanted me to create for their anime pillow. So there's that. And then this one up here, some guy owned a gas station chain and wanted me to create a proximity device that could detect when trucks were pulling up and then automatically, like big rigs, then automatically incur like a cryptocurrency transaction or something like that. So it was really weird. I got to discover my passion through these random requests that I was getting. But I wasn't exactly engaged with the traditional path of going to school and everything. So by the end of my high school years, I found myself in a place where not only did I not really apply to college, but I was not passionate about it. And yeah, I found myself at the end of summer, my senior year, and I was like, shoot, I guess I'm not going to college. What should I do instead? Luckily, I had some friends that were out in Montana that were working for Hack5. So I had a friend that was creating videos for the Hack5 channel. Basically, they saw some of the other content that I was creating, and they were like, hey, if you want to fly out just for a month or two and stack up some money, create some content, and figure out what to do from there, maybe land a job or something like that, that'd be cool. You could come out and do that in the meantime. So I decided to do that for a little bit, flew out to Montana for a couple weeks out in the sticks. Here you can see me on camera, and then here you can see me doing some Montana stuff, like skiing and climbing on top of a ski lift that I'm also not supposed to be on. But anyways, when I was there, this project sort of sprung out of serendipity. So my friend was actually working on a hardware project with another creator that ended up flopping. So he was left over with a bunch of hardware components that he had no clue what to do with. So he also saw that I was creating some hardware prototypes. And it was basically like, yo, if you want to help me sell some of these leftover components we have, and basically just create some sort of kit or something that we can use to just get rid of this stuff for some extra side cash, that'd be cool. We could teach soldering classes or things like that with them. So I was like, screw it, I think I can do that. But spoiler alert, the 2 weeks / month that I was supposed to spend in Montana ended up becoming a 1.5 year of running an intense startup, which is what I'm going to be walking you guys through today. So before we dive into the timeline of the product that I created, I first want to start out in short order by outlining some criteria for what I think constitutes an effective product design. And the distinction that I want to make here is between hardware and a product. I think this is probably a concept that's intuitive to a lot of people, but to make it explicit, I guess what qualifies a product is it has character. You have to really think about the user, so you have to think about things like ergonomics, you have to think about aesthetics. You also have to consider the fact that a lot of people that might be using your thing could be idiots that have no clue how to actually interact with it, and you have to make it really foolproof. Things like that. There's a lot more dimensions to it than just something like a motor controller, for example. So I'm going to talk about some key points that I think qualify an effective product design. So I think it can be really boiled down into 3 high-level points. The first 2 are a matter of scope. Number 1 is know your audience. That one seems simple. Number 2, so this one is a really huge pitfall that I see, especially in the world of open source design. And this is why the idea of creating a multi-tool or a hardware platform or basically an all-in-one device sucks. And then the third one, this one leans a little bit more towards qualifying an educational hardware tool. We'll talk about that later, but it's about making it fun and rewarding for your users to work with. So number 1, know your audience. It'd be easy to say, don't overscope, focus on your minimum viable product first, set reasonable timelines and things like that. But this is really an issue of scope that I think is massively overlooked. I see this all the time with devices that are even on the market, like Tindy, Crowd Supply, even Amazon and stuff like that. Like you can create like really killer designs that have really well thought out, well developed features and stuff like that. But if you don't know the audience that you're actually creating for, that's where things start to get really muddled. So I think there's 2 marks that you need to hit in order to accomplish that. And I think the questions you need to answer before you actually create a design are 1, what niche are you targeting? So for example, is it for cybersecurity enthusiasts? Is it for makers? Is it for hackers? And the second one, which is probably the most glossed over, is actually picking a specific skill level. So this is a point that I'm going to iterate throughout multiple points. There are multiple points throughout my presentation, but you have to have a really clear direction, and you can't really have an all sizes fit one kind of thing. You can't really appeal to everyone. So yeah, one of the biggest mistakes that I see is prioritizing features before your audience. It sort of works the other way around. If you get hung up on features, things start to get really nebulous. But if you know your audience, this helps to narrow down the scope. It helps you not only pick out features, but it also helps you from a marketing perspective, and we'll see why a little bit deeper in the presentation. So this brings me to my second point, which is why hardware platforms suck. So this is a little bit of an extension of that. I think this is a really lazy approach and a very common pitfall that I see, especially in open source design, which is this idea that you can create something that appeals to everybody. It's a terrible idea. It doesn't work. I know that from personal experience, but also from seeing this mistake having been made throughout multiple products that I've worked with in the past. From the user perspective, this sucks, not only if you're actually, I want to take a step back. Not only does this suck from a development perspective, because if you don't have a clear-cut product that you're developing and you have like all these different features that you have to support, that's a huge pain in the ass. But also from a user perspective, particularly if you're designing educational hardware, if you present too many options to your user, that just confuses them, particularly for beginners. For a beginner that's approaching a product, specifically like an educational hardware platform, they want to feel smart using this thing. They want to feel accomplished. They want to come away feeling like they're actually doing something. If you present them with too many options, like a pick your own adventure kind of thing, they're not going to be able to follow along linearly. And it ends up leaving them very discouraged. They'll put it away on a shelf and never touch the damn thing. Instead, what you should do is focus on doing one thing very well. We'll talk about this second point later on. I know it's very cool to have a multi-tool or a thing that supports doing all sorts of stuff, but if you do have alternate use cases for your device, which can typically be used by a more advanced audience, that isn't what you should be primarily marketing it as. That being said, there is some merit, I think, to modularity and extensibility. I'm not entirely discounting the idea of creating something that can be used as a platform, but this comes back to the idea of knowing your audience and also the idea of scope. So multi-tools are generally okay if you're keeping them behind the scenes and it's not the main point that you're sort of hinging your entire like marketing outlook on. You can't say like, oh, this is a multi-tool that does everything for everyone. It has like all the sensors in one. It does like all this crap. I think that's a terrible way to represent it. If you're targeting a developer audience, this is okay. Case in point, if you guys are familiar with Adafruit, Adafruit creates a whole line of boards. These are primarily oriented towards developers and people that know what they want to do with the product. If you're creating something that's meant to go in the hands of end users, like we're going to talk about, that's where this sort of doesn't really work. So I didn't get to finish filling out this slide here, and I also tried to blur out these projects so I didn't insult any makers in particular. But how many of you guys create hardware? Oh, one person? OK, how many of you guys have ever had the brilliant idea when creating anything? Actually, do any of you guys work on any sort of development of some sorts? Software, hardware, anything? Have you guys ever thought of the idea of making like some sort of generalized like platform or multi-tool or like some sort of all-in-one thing, or no? OK, I got a maybe from the one hardware developer. But most people that work in hardware, we're developers. We tinker with a lot of things. We interact with a lot of sensors. And at some point or another, a lot of us product developers or hardware developers find ourselves at a point where we're like, you know what people really want? We want an all-in-one tool that does basically everything. I have a friend that works at CrowdSupply. If you guys aren't familiar with CrowdSupply, they basically are a platform that crowdfunds open source hardware projects. And I asked them, like, how often do you guys get requests for people submitting like their all-in-one, like brilliant design ideas? And they said like all the time. It's basically takes up all their time just like rejecting the copious amounts of requests they get for that. But I was going to fill out this slide with a bunch of crappy examples I found on Tindy and CrowdSupply and Amazon and such. But this is what I call the banality of recreating the Arduino. It's a very common issue that I see, especially in open source hardware platforms. It's this idea that you can just create something that has all the sensors, all the features built in, give it to your user and say, hey, this does everything. You can program it. You can use Arduino on it. You can use Python on it. I think that's a very lazy approach. That's also a mistake that I made, which we'll be talking about just a second. But basically, don't do that. It's bad. So for another case study, we're going to take a look at Hack5, which is where I create videos and such. So Hack5 is an example of a company that I think gets it right with the way that they brand their products. And the reason why is they sort of offer this very clear-cut, single-use portfolio of hacking tools. If you guys aren't familiar with the devices that they create, these are for pen test engagements. So they have things like the USB rubber ducky, which is basically a keystroke injection tool that looks like a flash drive when you plug it in someone's computer, types out a bunch of naughty stuff. They have all sorts of other things like network implants, inline Ethernet implants, Wi-Fi hacking tools, and things like that. The point that I want to make with this is, so they also have this concept of like a payload deployment system where all of these devices are able to deploy payloads. Under the hood, a lot of these things operate the same way. Some of them even share hardware. But what I think they really get right is instead of condensing this into an all-in-one tool that can do all of these things, they break it up into very easy to palette devices. So it's really easy not only for beginners to approach this and say like, hey, I want to attack computers. Which device should I pick out? It's pretty intuitive. But another thing that I think they do very well is they set clear boundaries. So even though a lot of these devices also have like hidden or alternative use cases, they don't market it as being a multi-tool. They sort of hide those alternate use cases in their documentation, and they let the users discover that. I think that's particularly important to keep in mind when you're thinking about the skill level that you're targeting. Because this is another thing. It's also, so the target is pretty easy to scope out. In this case, they target hackers and pen testers. But the skill level is something that's kind of nuanced here. So for example, Hack5 products are targeted more towards an advanced audience. But secretly, they also target, in some sense, beginners that want to feel advanced. So where was I going with that? Yeah, so even though you might have alternate use cases for your product, I don't think it should be always at the forefront of your marketing. It makes things very confusing. So this is where we get into what I think qualifies a good educational hardware product. So at a very high level, we talked about scope in 2 points. You should basically do one thing very well and also know your target audience. From there, that'll help you narrow down exactly what features it is you want to develop. But we're going to take it a step further and talk about what I think actually qualifies a good educational hardware device. So in order to do that, I guess first I want to define what I think makes a good educational experience in some sense. I'm sort of freeballing here. So I think what would make a good educational hardware product is really something that drives or incentivizes the user to want to pick up the thing and learn and play with it on their own accord. It's really easy in the context of, I guess, like education, like in the classroom, to like set a device down in front of a student and say like, hey, use this thing, it's really cool, you're gonna learn how to do stuff on it. But like any other normal kid, I would probably subvert that if I was in school, throw it away and be like, no, I'm not touching this piece of crap. I think I think the hallmark of a good piece of educational hardware or a good educational product is really something that drives the user to want to interact with it themselves. It rewards them for using it, and they feel like they've actually learned something. So this is going to be an extension of the third point that I didn't talk about earlier, which is making it fun and rewarding for the user. And I think 3 points that qualify that are, number 1, some sort of reward incentive or points system. Number 2, having some sort of novelty to your device. This isn't essential, but I think it's a really big driving factor for what makes a device fun or engaging. And then number 3 is content. So in my opinion, content is king. I really wish I could probably devote an entire presentation to this one, but content is really a unifying factor between all skill levels, and also lends some support to your product in areas that it might be lacking. So we'll talk about that when we get to it. So number 1, make it rewarding. So what are ways that we can do this? Gamification is a pretty easy one. Having some sort of points or reward system is a really great way of letting your users keep track of their progress. It also taps in psychologically to the impulse to want to keep on, I don't know, using this product, picking it up, and keep on learning with it. An example of this is the Ponygochi. If you guys are familiar with that product at all, it's sort of a spin-off of old-style Tamagotchis, but for hackers. It's this tool that you can use to drive around, war drive, capture Wi-Fi network, stuff like that, and then if you don't do that enough, your character dies. So I think having some sort of points incentive and gamifying it is a really great way to make this a rewarding experience for your users. And also the idea of competition or having statistics that you can share, I think is really great. Not only does this, because I don't know, if you see like your friends also have this device and they have more points than you, naturally you'll want to kick their ass. So I think that's another great way to build community around this project and also around your products and get people to want to pick it up. How can you do this? You can tap into the human preservation instincts of keeping your digital child alive, and if they don't take care of it enough, it'll die. That's what I think is key to this. I think giving your users a mission is also a really great way to drive this. So I also conflate the idea of having a mascot into this point here. But having some sort of character or face that gives us life and personality is something that I think really drives the experience. So for example, with the Tamagotchi or the Ponygochi or something like that, being able to monitor this little icon I think is really compelling. All right, so this brings me to the third point, which I think is a really great unifying tool that's not utilized enough, and it's criminally underrated. So you can create a really effective product. You can have a really killer tool set. You can have really great features. But one thing that I think is really often overlooked is the human element to design. And one aspect where I think this happens oftentimes is the lack of content or the lack of a compelling argument or showcase for how to use your product beyond just like boring developer documentation. We'll talk about this a little bit more once I get to the Nugget timeline, but I think content is really effective because it can bridge the gap. It can bridge the gap between different skill levels particularly between beginners and advanced users. And in addition, it also provides some transparency and helps build a sense of community if people are able to gain insight to the things that you're developing. So we're going to take a quick look at two quick case studies here. So how many of you guys have heard of the Flipper Zero? Yeah, so this is a really popular tool that I think gets it right in a lot of senses, matching some of the criterion that I mentioned before. Quite obviously, it's a rewarding platform to work with. It's really fun, it's cute, it has a little mascot that encourages you to want to use it. There's a point system. I don't think the dolphin dies though, but still, people find this thing really fun to work with. When we take a look at the scope and the particular niche that they're targeting, it's mostly oriented towards hackers and tinkerers. One gripe that I have about it is it's a multi-tool. It's a sort of all-in-one platform. But the area where I think they do have this right is, first off, they have a lot of money, so they can scope out the more advanced features that advanced users would actually want in this thing. But this is another case where the skill level is a little bit nuanced. It's marketed towards beginners, but the secret audience is kind of hackers or more advanced people that are nostalgic for these old style like gaming consoles. But one thing that I think the Flipper is actually lacking on is the availability of content or high-level showcases that actually teach beginners that are interacting with this tool what they're actually doing. So there's a lot of really cool showcases that are packed into this. You can hack IR, you can clone RFID, you can do all these really cool things. And in some sense, it's rewarding. You can click buttons, you can like hack a bunch of stuff. And as a beginner, that looks cool, but you're not really actually learning anything. There's a bit of a dichotomy here where they do actually have really great developer documentation. And oftentimes with open source products, I see this. There's a lot of really good developer docs. So the nerds are able to dig into this thing and use it, which is why I think it's actually really popular with hackers. But they don't have a lot of really good beginner content around this. And I think that's an area where this sort of falls flat. I actually do have some non-technical friends that have purchased this device, and they almost never use it because they don't really have a use case for it. There's nothing to really learn how to do with it except like cloning cards and blasting IRTVs and stuff like that. So that's an area where I'm a little bit disappointed. I think they could do a killer job if they implemented content as part of their platform. I'm going to sort of gloss over this one, but Adafruit, I see this more as a brand, and we'll get to that in a second, but Adafruit is an example where it is appropriate in some sense to have a platform. We talked about this a little bit earlier, but even though they do create a very generalized platform kind of approach, I think where they do hit the nail on the head is they do have good unifying content, and they have showcases like, for example, how to build like a weather station with some of their platforms and things like that. That sort of provide their users with an idea of what they can do using this product. All right, so now we're going to dive into the Nugget timeline. We're going to see how this project evolved and see if it meets the marks of the criteria that I outlined in the past few slides. We'll see how well it holds up against that. So starting off with the initial ideation and the initial concept for how this product was developed. So when we were first creating this design, as I mentioned, we didn't really set out to create a product. It was more a piece of hardware. My friend just wanted me to create basically a platform to house all of these components so we could sell it as a kit. We didn't really have an idea, a unified idea, that made this compelling or able to stand up on its own as a product. So basically, we just had this Game Boy-esque form factor that I came up with. We didn't know what to do with it, so we ended up running some open source Wi-Fi hacking software from a previous project that my friend worked on. That wasn't enough, so I decided, why not make it cat-themed? So I actually want to distract from that for a second to talk about the particular microcontroller that we ended up using on this board, because this is actually pretty crucial to how this project ended up developing, and also reaches back to my point about extensibility. As I said, in some cases, there is a good excuse to have a multi-tool or a platform or something that's somewhat extensible. And I think generally in the early stages of creating a product, keeping it as open and flexible as possible is a good idea. In this case, we were creating a prototype, so we based everything off of easy to find, easy to source components. They're all through-hole. And one of the things that this hinged around was a particular microcontroller platform called the D1 Mini. So I was very familiar with this platform. I actually developed some of my other designs that I was talking about, like the Probe Hunter with it. But this is basically a really ubiquitous Wi-Fi microcontroller that you can find for like $2 to $5. And it's really sweet. It's really easy to prototype with, and most of my designs are based around it. Because you can find these really easy to source, basically plug and play modules that you can stack on top of it. Like if your design needs an SD card module for logging data, just buy one of those for $1, slap it on top, and then there you go. Your design now supports micro SD card logging, or things like that. So this was actually a really good decision that ended up impacting how our product developed, since we were designing around this particular platform. So yeah, we'll keep that in mind. An example of some other things that I've developed with this. In the past, just to show you guys, these don't really look like anything, but in the middle here, I created a war-flying drone rig using this microcontroller, where I was able to stack a GPS on top of it, an SD card, a LiPo battery, and was able to use this to track down my friend across the city. I use this all the time just for how small and versatile it is when I'm war skating. I can just slap it on my skateboard like so. And it's one of my favorite form factors to work with, really. I also glossed over this a little bit. There's a lot of points that I'm missing, actually. But sort of what inspired me to work with microcontrollers, or what I found really attractive about them, was particularly the low cost. As I mentioned, growing up, one thing that I didn't have a lot of access to was like more expensive like toolkits. I didn't even have a computer until high school and stuff like that. But I found microcontrollers really attractive because they're really low-cost devices that you can use for a variety of applications. And they've gotten like so fast, but also so cheap. And they keep getting more and more advanced over the course of years that they can even be used for hacking engagements, signals intelligence, and stuff like that. And that's what I find particularly fascinating about them. One of the things that I do for Hack5 is I create various hacking showcases. Like a recent video that I did about 2 months ago was how you could be hacked through snail mail. Basically, the sort of the presentation that I did for that was I created a microcontroller rig for $10 using this exact platform, put it inside of a UPS box, and you could actually ship it out to a company addressed as a fake name, have it sent back to you, but while it's there, it actually gathers reconnaissance on like the network that it's deployed around. But I find microcontrollers really interesting. For their low cost, they're extremely versatile, they're very fun to work with, and particularly if you're creating like an educational hardware platform, or if you're designing for users that might not have a big budget, this is where I think there's a lot of merit to having a microcontroller-centered design. It's very low cost, relatively easy to work with. But yeah, I love microcontrollers. Oh yeah, so I didn't really talk about this, but these were the initial designs that I created. This one is called the Hack Cat. It's got some buttons, it's got a screen, it's got that microcontroller on the back. Just for fun, I created this one. It's kind of stupid. It's called the Long Cat. It's got a battery on the back of it. But as a joke, I was like, hey, why don't we create a cat-shaped one? Kind of stupid, right? And I ended up drawing this kind of crappy profile for some sort of disfigured cat. That was the first iteration of the Nugget. My friend and I ended up settling on this isometric design, which became the first iteration of what was then called the Nugget. It started out as a joke. It ended up becoming our flagship product, and people really loved it. So talking about the software that we actually deployed on this thing, so as I mentioned, we didn't really have a unified idea or anything that made this platform unique to work with. It was just a thing that housed components that people could solder together, and the idea was we were going to sell it at workshops. Also, I really have to speed up. I have 20 minutes. But there's this really great open source software that's created by one of my friends in the community, Spacesoon. It's this open source Wi-Fi hacking software called the Dauthor. Basically, it does a whole bunch of nefarious Wi-Fi stuff. You can boot people off their networks, run all sorts of pranks and stuff like that. So we decided to just run that lazily on our platform. I'm sort of going to breeze through the timeline here, and at the end, I'll sort of talk about the implications and how it ties into my higher level points. But basically the first trial run after creating this product. How did we actually sell this thing? Well, for one, we were kind of lucky. We had a platform at Hack5. So the very first thing I did was I just created a video showcasing how this thing could be used for running and detecting Wi-Fi attacks. So the algorithm hates hacking content, so I had to take a defensive skew for this. So instead of showing how I could use this in order to do nefarious stuff, I also wrote a separate program for detecting Wi-Fi attacks and titled the video that. People caught on to this. They really loved it. And this is also sort of what I'm talking about when I say like content is very unifying. This thing wasn't a fully polished product at all. If anything, it was quite bare. But people kind of saw a vision in this. They saw the novelty, especially the cat theme to it, and they liked it. So they purchased this product. And we ended up hosting a couple successful workshops with this thing. Soon enough, we found ourselves at a point where we actually managed to sell out of these damn boards. And we were pretty surprised because we never intended for that to happen. So what did we do from there? Well, we decided to double down, start creating more. We ordered more components for these things. But this is where we hit our first mistake. Since we weren't really creating a product and didn't know what we were doing, this is when we started marketing this as basically the ultimate multi-tool to do everything. It was for Wi-Fi hacking. You could even program on it. You could solder with it, which is basically just because it's a glorified microcontroller on a circuit board. I sort of stuck to my guns. I stuck to what I knew how to do and just created more Wi-Fi hacking content to sort of sell this thing. We were getting consistent orders with this about 3 or 4 months deep into the project. Once we had enough comfortable money from this thing and started seeing more and more users use this every time, and also like spikes in our sales every time we would put out a video, that's when we decided to do some experimentation to see what people, I don't know why that picture is blocking that. We decided to do some experimentation with this design, sort of play around with it, and try to, I don't know, brand it a little differently. But we started creating different color variations and things like that. When I talk about extensibility and not creating a hardware platform or like an all-in-one multi-tool, actually maybe I'll save that point for the end. But the point is a thing that you can do if you have a basic enough product is you can create variations off of a base design, and you can still sell those equally as well. One thing that I was really surprised to find out was just by creating different color variations, people started not ordering just one nugget, but we would start seeing like 4 orders from the same person, just like in different colors, which is interesting. Another thing that we played around with, which sort of leans into the gamification theme, we hosted like a Halloween workshop. I ended up creating a custom like Halloween themed nugget where I took the D-author and I basically just slapped like a jack-o'-lantern face on it and also had them like program some NeoPixels. People loved that. And I think that really speaks to just having like a cute design. Some of my other children, you can see here, and sort of the evolution process of the Nugget down below. You can see that this Nugget here is smashed. This is the point in which we decided that we needed to have a faceplate to protect it. You can see down here sort of how that evolved from a naked Nugget to a cased Nugget to the final design, which is a little bit more of a fully polished console. Oh boy, so let's talk about this. So when I talk about intuitive design, this is something that everybody knows how. Okay, I'm gonna skip that one. Okay, so a little bit short on time, so I'm gonna rush through the next couple of slides here. So when I was talking about the D1 Mini form factor and why we found that particularly useful for creating various iterations of different things that we were making, I actually lost my point. So anyways, the manufacturer of the D1 Mini, at some point or another along the development process, they came out with this alternative design that housed the ESP32S2. It's a slightly more advanced version of the microcontroller we were working with. It's really cool. It's faster. It has native USB, which means it can emulate USB devices. And it was in the same footprint. It did a lot more. But one thing was it didn't offer Wi-Fi hacking since the developers of this product cracked down on people that were using their product for nefarious purposes. That sort of impacted the demonstrations that I was creating. But what was really cool about this is it actually offered a feature that the other one didn't, which was a thing called CircuitPython. So CircuitPython is a really cool language for microcontrollers. It's basically self-hosted Python on a microcontroller that you can access over USB. So we were like, hey, that's cool. That really solidifies the idea of us having the perfect all-in-one multi-tool that can really do everything. It supports CircuitPython now. So this was a terrible branding decision on our part. We decided to just create another variation of the Nugget on our store. And the dichotomy we had was we were selling D1 and S2 Wi-Fi nuggets. So you can imagine that was a terrible branding decision. People bought the wrong products. They got pissed at us. And we figured that we had to do something about it since it lacked a vision. I'm really going to speed through here. But the key things that we leaned into that ended up working out great were, first of all, gamification. This is the point where I decided we needed to have a unique vision of our own for this product, our own software, and stop just using random open source software or telling people that you can use Arduino and CircuitPython and all these things on it. So I decided to write my own firmware for it. This is where we learned an important mistake that hopefully I'll loop back around at the end of the presentation, which is this idea of feature parity. So keep in mind at this point, we still weren't developing a product. We were just sort of going with the flow. We didn't take any time to consider who our audience was, what we were developing. I was sort of just playing it by ear based off like what people were buying more based off the content I was creating or not. So I decided to lean into Wi-Fi hacking. Again, I didn't really scope out what I wanted this Wi-Fi hacking firmware to do. So I just wanted to create a Wi-Fi hacking multi-tool. I wanted it to do everything. And my basis for that was Space Rune's Wi-Fi deauthor. I basically was just chasing feature parity, trying to replicate everything that his software could do. Everything that software could do through our platform. This is also my first time developing like a real embedded system, so a bunch of crap happened, like me learning how to work with buffers and stuff being screwed up. So that was quite a nightmare. I spent 2 months teaching myself like a whole bunch of stuff about really low-level embedded things in order to design this. But about 2 months deep, we found ourselves at a point where we were still selling the damned D1 and S2 nuggets. People were still confused, buying the wrong thing. And I was overwhelmed. I not only didn't know enough to keep up with the features that I was developing, but we also didn't have a good enough scope to define what this product really did besides being an all-in-one multi-tool. So that's when we decided to split it up into offensive and defensive Wi-Fi hacking. We came up with these concepts of creating a software called the Invader for offense and the Defender for defensive Wi-Fi hacking purposes. But that didn't answer the question of this floating product we had called the S2 Nugget, which basically did nothing. We were selling it as a board that ran CircuitPython. You can see it, all it's doing here is flashing lights. There's not even anything on the screen. It was quite sad. So I got especially desperate once my friend started putting wet anime eyes on the product. I was like, oh God, we really have to do something about this. So that's when we took time to sit down and think about what we wanted this to look like in terms of a product that a person could pick up and intuitively figure out how to use. Oh God, I really have to speed up. So that's when we discovered a project called the Pico Ducky, which is basically a keystroke injection tool designed for the Raspberry Pi Pico. You plug it into someone's computer, it runs an attack. Like in this case, you can see running on the Nugget. As I mentioned, CircuitPython is only supported on the S2 Nugget, and this Raspberry Pi Pico project, which was developed in CircuitPython, ported over really easily. So we figured, hey, we work for Hack5. They create keystroke injection products. Why don't we also create a keystroke injection product? But instead of being like a black box oriented towards hackers, we add a educational dimension to it where it's easy for beginners to use. You can watch the feedback on the screen instead of it being hidden behind like a terminal or something like that. And really lean into this product being beginner friendly. So you can also see we made some steps forward in terms of making the design more user friendly. I made like a case for it that looks more resembling of like a console or something similar. You have a little cat. It shows you whose computer you're screwing up and things like that. Yeah, so our product naming got really confusing. So then we had a separate nightmare where we decided what we wanted to do instead of sticking with this platform that we already created was create another separate platform that was a fully polished product. It was going to be a surface mount version of the Nugget. I couldn't find any good pictures, but here you can see a crappy prototype I dremeled on Perfboard, and then also this ugly, bodged surface mount version that I developed. So I spent a month chasing that, which wasted a lot of time. But my point there is we still really weren't thinking about our customers and what they wanted. I was going on a bunch of side quests. And this made things very confusing. So yeah, when I was talking about with the Wi-Fi Nugget, that split off into the Invader and the Defender, and then the S2 Nugget got rebranded as the Rubber Nugget, which was a portmanteau of the USB Rubber Ducky and the Nugget as a USB attack tool. And then I came up with the brilliant idea of creating the Deluxe Wi-Fi Nugget, which is this piece of crap surface mount nugget that I was working on developing. Things were really confusing, is the point. But anyways, we got to a point where we finally discovered our niche after creating some videos showcasing this thing. It turned out people actually liked it. I hosted some workshops to get feedback from the community, had people actually use this thing. Yeah, I'm gonna go ahead and skip through the rest of these, but point is, we ended up creating what finally resembled a fully finished product. It had somewhat cohesive branding. We had graphics for it, we had packaging that I designed for it. And it was something that we could really boil down into a cohesive product that we could explain to someone, really. So yeah, we ended up doing a soft launch of about 300 of these. I assembled them by hand, packaged a whole bunch of them, and fun stuff like that. And I think we sold out after 2 days. Anyways, at the end of this, I'm going to wrap up this Nugget timeline here real quick. We ended up having a little bit of side money to start exploring the next steps that we wanted to take with the Nugget, which sort of brings us to where I am today. So we decided to take a step back, assess what people really wanted with this design, and get more feedback from the community. This is something that I'll talk more about in the wrap-up in just a second here. But I think community is a really important aspect of any product design, particularly if you're creating an open source project. You can't wait until your product is done and fully polished, in my opinion, to put it out there. People are going to find flaws and stuff like that. It's going to be screwed up anyways. I think that's sort of something that has to happen over time. And I think one of the most effective parts of our development process was actually getting these designs in front of people at workshops and things like that, having them test it out, find the bugs on the go. Yeah, but doing workshops and interacting with the community was a really important part of this for us. We started screwing around with other things like more use case demonstrations. In this case, actually maybe I'll skip over that one. Oh God. Yeah, but we started going to conferences and stuff like that. This one I'll skip, but I was hoping to talk about some hardware design tips as well. This was an unfortunate disaster that happened. We ended up ordering 500 of these Nuggets before DEF CON. All of them were broken because the manufacturer made a mistake on the microcontroller design, so I had to bodge solder them by hand. It took me like 2 weeks straight. Maybe in a future talk I'll go over design tips and such. But yeah, that brings me to the end of the Nugget timeline. So I'm going to briefly wrap up by talking about what we learned while building this product, and also, in effect, building a brand. So I'm going to skip ahead to this one first because I think it's the most pertinent. As I said, when building a product or a brand in this event, I think one of the key things is being able to tell a story with it. This sort of reaches back to what I was talking about with having a mascot, making it fun, making it rewarding, and things like that. If you're able to build a compelling narrative around your product, if you really know who you're marketing it towards, and you're able to communicate that, whether it's through content or whatnot, and you're able to use your products as a sort of character to market this, I think that's a really great way to make your product compelling. And I think some qualifying pillars for that are having really good cohesive branding. Don't have like nebulous like verbiage in the marketing that you're putting out there. Don't call your thing like a multi-tool. I think that's a terrible thing that you could do. And the ways that you can do this is you can communicate it through content, and you can have cute icons and mascots that represent your design. So for this first point here, this is one that we learned pretty hard, and I wasted a lot of time chasing after. Don't really worry about competition too much. If you know your niche, if you know who you're targeting and what your product offers over other devices, focus on that instead. That's the edge that you have over other devices that are out there. And if you're creating content, as I said, content is really king when it comes to this sort of thing, because it's what a lot of products are lacking in dimensionality. If you have good content that's able to sell it on features that other devices might not have, I think this is really the strongest thing that you can do. Number 3 is community. Tapping into your community is really important. I think, as I talked about in that last little section there, that's something that really contributed to how this product developed. Being able to put this out there in front of people, and also having content to support what we were creating and sort of communicate our vision with people is really what helped us hone in on having a cohesive project over the course of time. So I think building a community around your project is very important. And the last thing is diversity. So I think this can happen basically in 2 different ways. Project diversity, number 1, don't build a multi-tool. That's something that I've iterated. But number 2, as I talked about sort of with the Hack5 portfolio case study, building a monolithic business where you have like a multi-tool or an all-in-one thing is a terrible idea. But anyways, yeah, that was quite exhausting, but thank you guys so much. Yeah. Oh yeah, if you guys have any questions.
If you have any questions, I'm going to come up with the mic. Please hold it really close.
Yo, so how do you learn to tell yourself and your customers no so that you don't become a general multi-purpose tool as you're receiving feedback?
You have to be, I guess, let me think about that. In some sense, you have to be really confident in what you're representing. Like, you learn to develop the rhetoric over time. Like, the way that we describe the product now is like, it's an educational tool to teach beginners about hacking and cybersecurity. You sort of learn to hone it over time. But once you start communicating that point over and over in the content that you're creating, for instance, and once you create enough like high-level showcases, that's another thing that I really wish I hit. Showcases are really important. Oftentimes I see with open source products, they have really great developer docs. There's like all these use cases for how, as a developer, you can use this thing. But as a user, there's not a lot of good showcases like, hey, here's how to build a specific project. Here's this really cool thing that it can do, and here's how you can replicate it, or giving them lessons with it. I think that's a really important aspect of it, but really having a no-nonsense, like, just like really cut out the verbiage when you're marketing it. Just have like one sentence that can really explain it well and show your users that it actually does that thing. Yeah. Does anyone else have questions? Sure.
Were your neighbors running like WPA networks? Is that how you were getting
WEP. I lived in a old folks community.
Gotcha.
There were a lot of old folks around me, I could say that. Yeah. Yeah. Yeah, thank you guys so much. Yeah.
What's the easiest way to program it? Do you prefer CircuitPython or Arduino?
So when I'm developing firmware, definitely Arduino. It's just a lot faster. It's compiled. It's much better for low-level stuff. When I'm teaching workshops, I find CircuitPython is generally more accessible. It's a much more high-level language. You can literally just copy and paste codes. Beginners can read it and really parse out what it's doing.
What resources would you point someone towards who's very familiar and comfortable on the Arduino and Python side, but wants to get more involved on the hardware and circuit board design side?
Specifically like circuit board design, like actual
Yes.
circuit boards? Okay. To be honest, that's something I struggled with, circuit boards specifically. There's not a lot of really good resources that could point you there. I started out with Easy EDA. It's a really great online suite that you can tinker around with. It's fairly intuitive. I think that lays a lot of good groundwork for picking up other more advanced tools like KiCad. As I mentioned, I didn't have access to more expensive stuff like SolidWorks or EagleCAD or things like that. So KiCad is a really great open source alternative to that for circuit board design. In terms of getting more involved in the hardware space, I think sort of the way I started learning stuff was I figured out like a project that seemed accessible to me. Like one of the first projects I worked on was I wasn't always home, so I wanted to create like a fish tank feeder like for my fish. So I was like, okay, what can I do? What can I make in order to have that happen? So I learned about For instance, how I could control like a servo motor, how I could implement like a real-time clock to keep track of like time and stuff like that. I think if you can figure out like some easy projects that you want to do, that'll not only like keep you motivated to learn enough to do those things, but over time you'll sort of like figure out all the necessary skill sets. I'd recommend checking out Adafruit. They have really good guides for hardware stuff. SparkFun, some other maker brands like that. They have a lot of good tutorials and also hardware. If that answers all your questions. Yeah.
First of all, thank you for doing your presentation. And
Yeah.
I just have to say, like, the fact that you've done so much in what would be such, considered
Yeah.
a short amount of time, like, that is amazing. My question for you is, what does your future look like? What does it look like for the products and company that you're making? Have you thought about that? What does it look like to you?
It's all very hazy right now, that's for sure. This project actually came to a standstill, unfortunately, due to some internal stuff that was happening with people that I was working with. Right now I'm sort of pursuing contracts and working on my independent brand where I'm back to working on like wireless security focused stuff and things like that. I want to get more involved. I don't know, I come from a much more of a hardware background, but I'm looking to lean more into security. I've sort of been straddling the line between the two and using content actually to navigate that, communicating to other beginners and things like that. But I'm hoping to learn more mostly about things that I've always been interested in, like more signals intelligence stuff, and also getting more involved in the community. This is the first time I've done a conference talk in a little bit. I'm looking to get back out there because things have been really slow for me and quite bogged down over the past couple of months. So yeah, I also got 3 hours of sleep last night writing these slides, if you guys couldn't tell. Yeah, shout out to, where is he, for the chocolates you gave me. It's powered me through this. Cool. Does anyone else have any questions? Oh yeah, I'm also hosting a workshop next week at Crash Space. My friend Jay over there, he runs an awesome makerspace over on the west side of Los Angeles with the Nugget. So if you guys are interested in that at all, I'll put out a paper or something up here. You guys can sign up for that if you'd like. If you're interested, I'll send out an email with that. If you want to grab my business cards for contacting me or stuff like that, that'll also be up here.